There are times when experimenters are less interested in predicting differences in behaviour as a result of an independent variable. Instead, they want to investigate whether variables are associated together, and this is known as the correlational design. For example, if we were to consider the relationships between spelling ability and reading scores in children, a researcher might predict that over the whole range of spelling ability and reading ability, those who are good spellers will also tend to score highly in a reading test, while children at the bottom end of the spelling scale will not do so well at all. This might be important if you want to predict good potential readers. So children will be given a spelling test and a reading test, but this time neither of the variables will be independent or dependent. The researcher will take measures of both variables in order to see whether those children who score highly on one also score highly on the other. The correlational design. The object of which is to test the experimental hypotheses that children perform on reading well will also perform well on spelling, and that these variables correlate with one another. There is one point that you should notice about a correlational design. Because neither of the variables are being manipulated by the experimenter, it is not possible to predict which variable is having an effect on the other. All we can say is that there is a relationship between the two variables. Here we are looking at a correlational data set within SPSS. It looks at 4 pieces of information: salary, age, years, and beauty. And we call this the supermodel data set. If we look a little bit closer under variable view, we can see it's salary per day, age in years, number of years as a model, and attractiveness. Now, some of these variables are going to correlate with one another. Can you think which ones would be most closely associated? So what we'll now do is run a correlational analysis to see if your hypotheses are correct. Analyse, correlate, bivariate. And here we put across the variables of interest: salary, age, number of years as a model, and how attractive they are. And we look to see which of these are highly associated using the Pearson's correlation coefficient. So what we get here is a correlation table, and you can see that it repeats itself. So we're only actually ever interested in one side of the triangle, not both, because it repeats itself. And we can start looking at the correlational relationships and the significance levels. So let's have a look and see if there are any very high relationships. So this looks quite high, 0.96. That is almost a perfect correlation between age in years and number of years as a model. So this is hardly surprising that this is a very highly correlated relationship. In fact, it has what we call collinearity within it, which suggests it is actually measuring the same construct. Then we would want to look and see what other statistically significant relationships there are. So age in years, again, statistically significant at 0.397, is correlated with salary per day. Let's look at attractiveness. Attractiveness is modestly related to age in years and modestly related to years as a model. We make some inferences from this data about the extent to which variables within this data set are related to one another.